we have just learned that spring tide occurs when the sun, moon and earth are in a straight line. Now, in this position, what happens is that the water bodies present on the Earth's surface are attracted by the moon and sun simultaneously in the same direction. See, therefore, the water bodies also get attracted in the same direction. So what happens is that there is an extreme rise in the water level, which is known as spring tide. Therefore, the height of spring tide is 20% higher than the ordinary tide. See, this is an ordinary tide when the water bodies are attracted only by moon. But when the water bodies get attracted by both moon and the sun, the rise is this much. That is 20% higher. So, the height of spring tide is 20% higher than the ordinary tide. Let us consider another situation. In this situation, a heavy furniture is being pulled by two persons in two different directions. This person pulls the furniture in this direction and that person pulls the furniture in that direction. The persons are in a perpendicular direction and the furniture moves towards the person who pulls it by a greater force. So now we will see what happens when the sun, moon and earth are in a perpendicular position. So during the process of revolution, the sun, moon and earth comes in a perpendicular position or are aligned in 90-degree angle. So this line, the dotted line, represents the line of gravity. So here you see that the sun pulls the water bodies in one direction while the moon pulls the water bodies present on the earth's surface in another direction. So the water bodies get attracted by moon and sun in two different directions. So here what happens is that there is not much rise in water level. This situation is called neap tide. So neap tide occurs when the moon, sun and the earth are in a perpendicular position. That is, when they are aligned at 90 degree, the water level does not rise much and this situation is called neap tide. Now, in our previous slide, we learned that neap tide occurs when the sun, moon and the earth are in a perpendicular position. That is, when they are aligned at 90 degree. See, they are aligned at 90 degree. So, in this situation, the water level does not rise much. Why do they do not rise much? Because the sun and the moon pull the water bodies present on the earth's surface in two different directions. See, the sun pulls it in this direction while the moon pulls it in this direction. So, the water bodies are being pulled in two different directions and therefore, we do not observe much rise in water level. So, during neap tide, the height of water bodies is 20% lower than the ordinary tide. We see that the sun, moon and the earth are aligned at 90 degree or in a perpendicular position. So we do not have much rise in water level. In fact, the height of neap tide is 20% lower than the ordinary tide. Now, we have already learned that what is a tidal range. A tidal range is the difference in height between a high tide and a low tide. So, the difference between a high tide and a low tide is called tidal range. Now, we have learned that during spring tide, the water bodies present on the earth's surface are attracted by a greater force. Why so? Because the sun and moon attracts the water bodies in the same direction. Therefore, we can observe an extreme rise in water level, or we have higher high tides and lower low tides. So the difference between high tide and low tide, that is the tidal range, is more during spring tide. Now let us see what happens during neap tide. We have learned that during neap tide, the sun, moon and earth are aligned at 90 degree, or they are in a perpendicular position. So the moon attracts the water bodies in one direction while the sun attracts the water bodies in another direction. That is, the gravitational force of the moon and the sun do not work in the same direction. So we do not have much rise in water level, and therefore we have lower high tide and higher low tides. So you see that the difference between the height of high tide and the height of low tide is not much, and therefore tidal range is much less during neap tide. So the tidal range, that is the height difference between high tide and low tide, is more during spring tide and less during neap tide. Now before we proceed with our lesson, can you help me to answer this question? In which of the following cases tidal range is more? Is it more during spring tide, neap tide, high tide or low tide? Well, the correct answer is spring tide, because we just read that tidal range is the difference between the height of high tide and low tide, and during spring tide we have extreme rise in water level, that is higher high tide and lower low tide. So the tidal range, that is the difference between the height of high tide and low tide, is more during spring tide. So the correct option is spring tide. Now we have learned that high tide and low tide occurs every day. Now just see that the difference between these tide is not same. So this chart displays the tide timings in a particular place, Kolkata, from 14 January to 16 January of the year 2022. On 14 January, high tide occurred at 11:09 am. On 15 January, another high tide occurred at 11:51 am. Now we will calculate the time difference in these two high tides, that is the morning of 14 January and the morning of 15 January. See, from 11:09 am to 11:49 am, the time difference is 40 minutes. And from 49 to 51, what is the time difference? It is of 2 minutes. So if you add 40 and 2, you get a time difference of 42 minutes. So you see that there is a time difference of 42 minutes in the occurrence of high tide on the morning of 14 January and on the morning of 15 January. So the time difference between the high tide of two consecutive days is 42 minutes. Now we will do the same calculation for low tides. Just see that low tide occurred on the morning of 14 January at 6:46 am and on the morning of 15 January on 7:34 am. Now we will calculate the difference in these two timings of low tide. Just see that from 6:46 to 7 am, the time difference is of 14 minutes, and from 7 to 7:34 the time difference is of 34 minutes. So if you add 14 and 34, you get a time difference of 48 minutes. So there is a time difference of 48 minutes in the occurrence of low tide on 2 consecutive days, that is on the morning of 14 January and on the morning of 15 January. So now you can pause the video and calculate the time difference for the rest of the high tides and low tides. So just notice that from this time chart, we can find that the high tide and low tide do not occur at the same time. Rather, there is average time difference of 45 to 50 minutes in the occurrence of tides on 2 consecutive days. The main reason behind change in timings of tides is the simultaneous occurrence of Earth's rotation and revolution of the moon around the Earth. Now we know that the Earth takes 24 hours to complete one rotation, while the moon takes approximately 27 days to revolve around the Earth. Now, every day the moon's position shifts by 13 degrees. So when the Earth tide's center, that is point A, completes one rotation, the moon's position is already ahead, that is it shifts from point P to point Q by 13 degrees. To travel this extra 13 degrees, the Earth takes 52 minutes to align with the moon's position. So this is the reason why every day the tide timings changes. So from the previous animation, we understood that every day tide timing changes by 52 minutes. That is, a tide's center takes 52 minutes extra to align with the moon's position. Now you must be wondering why time changes by 52 minutes particularly. To understand this, we will have to perform a numerical. Well, we know that the Earth is a circular object and therefore it has 360 degrees. We also know that the Earth takes 1 day or 24 hours to complete one rotation. In other words, we can also say that the Earth takes 24 hours to turn or rotate by 360 degrees. So to rotate 360 degrees, the Earth takes 24 hours. Now if the Earth turns by 360 degrees in 24 hours, then by how many degrees will it move in 1 hour? In order to find out this, we will have to divide 360 degrees by 24 hours. So as mentioned just now, we have to divide 360 degrees by 24 hours. Now we shall reduce this expression. So this expression will turn to be 24 ones are. So this expression will reduce to 15 by 1. Thus we can say that the Earth turns by 15 degrees in 1 hour. So as mentioned just now, we found out that the Earth takes 1 hour to turn by 15 degrees. Now we know 1 hour is equal to 60 minutes. Thus we can also say that the Earth turns by 15 degrees in 60 minutes. Now let us reduce this expression again, that is 15 by 60. So if you simplify this 1 and 4, you will get 1 by 4. Now this is 1 degree and 4 minutes. In other words, we can also say that the Earth takes 4 minutes to turn by 1 degree. or it turns by 1 degree in 4 minutes. Now if the earth turns by 1 degree in 4 minutes, then how much time will it take to turn by 13 degrees? Well, this is very simple. If the earth takes 4 minutes to turn by 1 degree, then to turn by 13 degrees, it will take 13 into 4, which is equal to 52 minutes. So the earth will take 52 minutes to rotate by 13 degrees. So as mentioned just now, the earth needs 52 minutes to travel 13 degrees more. So this is the reason why every day the tide timings changes by 52 minutes. So as mentioned just now, every day the tide timings changes by 52 minutes. In other words, there is a time difference of 24 hours and 52 minutes on tide timings of every consecutive day. That is, the difference between the tide timings of 2 consecutive days is of 24 hours and 52 minutes. So this point A will take 24 hours to complete one rotation, that is to come to this position, and by that time the moon's position will shift by 13 degrees. So to align with the moon's position, this point A will take 52 minutes extra. Thus, we can conclude that there is a time difference of 24 hours and 52 minutes in the tide timings of every consecutive day. So till now, we have discussed about spring tide, neap tide, and how tide timing changes every day. We shall now discuss about various importance of tides. Tides are indeed very important for human beings. We can harness tidal energy to produce electricity with the help of turbines. This is mainly done in coastal regions. Now, tidal energy is a very good source of renewable energy. This energy does not pollute the environment and it is very cheap. Thus, tides provide us with a good source of renewable energy. Look at this candle. Here we can see that the water body is full of dirt and debris. This is the condition of a low tide. Now, how will this dirt and debris be removed? Well, during high tide, we know that the water level rises. This increase in the volume of water bodies washes away all dirt and debris. Thus, high tide keeps the coastal areas clean and dirt-free. We know that high tide and low tide occurs every day. So every day there is an increase and decrease in the level of water bodies. Now due to this continuous movement in water bodies, the ports mainly in cold countries do not freeze under the influence of tides. Now there is another importance of tides. We know during high tides there is a massive increase in the level of water bodies. This increased amount of water are sometimes collected in areas known as salt pans. In these salt pans, the water evaporates, leaving behind salt. Thus, salt pans are put up in coastal areas to produce salt during high tides. So just now we discussed about various importance of tides. We learned that tides are indeed very important for us as a good source of renewable energy, that is tidal energy can be harnessed from tides. In fact, tides also help to keep the coastal areas clean and they also do not allow the ports to freeze. In fact, salt can be manufactured during high tides. So in today's lesson, we discussed about spring tide, neap tide and various importance of tide. So this is all about the chapter of hydrosphere. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at deltastep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.